I just mentioned FDDI and fiber-based token rings. Fiber Distributed Data Interface, FDDI, is a fiber optic-based token ring. It uses token passing architecture, but unlike normal token rings that were a single ring, logically instantiated to run clockwise or counterclockwise, we have two rings with FDDI. One ring concentrically inside the other. One running clockwise, one running counterclockwise. So they run in opposite directions, and they are going to be bridged. They're going to be connected together so information can pass between them. One ring is used, the primary ring, the secondary ring is a backup ring. It's only used if the primary were to fail, and information flows in opposite directions around the rings from each other. But we are able to have this, as we said, used over great distances because the attenuation distance, the attenuation rating for fiber optic cable is much, much bigger, much longer than a traditional Category 3 or Category 5 Ethernet cable, a copper wire cable, which is rated, attenuated at probably about 100 meters, approximately 300 feet, and before we have to boost the signal. FDDI and fiber cable in general is going to attenuate at roughly about 2 kilometers, so 2,000 meters, which is going to be much, much longer of a distance before we need to boost signal strength, and as a result of that, fiber rings can be much, much bigger. They can run for miles and transmit data at very high speed. So we do see this running in large areas where we're laying a lot of fiber. We see it underlying metropolitan area networks and city cores. This is what the telecommunications, now internet service provider / cable companies are laying down and using in some areas to provide high-speed fiber. So this is the kind of technology you may very well come across. Token passing, as we talked about, and the token ring concept uses the token. You've heard me mention that. And the token is just represented here by the oval with the ones and zeros in it, which is the data that's moving across the network, being transmitted with the token. And so the token gives us the ability to be able to transmit around the ring. If we hold the token, we have the right to be able to transmit. If we don't, we have to wait patiently until somebody gives it to us. We've talked about different kinds of network designs, the star, the bus, the token ring. These are all topologies. We now have to overlay on top of that, as we continue to build our baseline knowledge, the concepts of different kinds of network design, right? We have topologies, how the network is structured, star, bus, etc. We now have local area, wide area, metropolitan area, personal area. These are all different kinds of network designs that we can use in terms of how we're going to structure transmission. So a local area network, relatively small area, we use these all the time at work. You're using one right now to communicate with me and interact in the class. I'm using one to record all this information, transmit it, and send it out to you. We're also crossing through a WAN to be able to do that while you download the class and actually watch it through a connected interface over the cloud, through the internet. You're actually doing this over a WAN down to a LAN. So local area network is going to be a relatively small area, divided off typically within an office building using a star bus topology. We use one or more switches to connect the individual nodes in the LAN together. We connect those switches through a bus, through an uplink. Those go back to some sort of central routing and or central wiring location where we will connect to one or more routers that will be gateways that will take us out into other networks. And so a local area network is the kind of network we're used to using all the time. You may have one at home that's called a SOHO, a small office, home office network. You may have an office-based one, a campus-based one, depending on where you are and how you work. But a LAN is pretty ubiquitous today, local area network. We'll talk about other kinds of networks a little bit later on. As I mentioned, things like the wide area network, a CAN, a campus area network, a MAN, a metropolitan area network. We'll talk about all these different kinds of networks. When we use these kinds of networks, we have to have what are called services, network services, to be able to use them with. We've talked about DHCP a little bit earlier. This is how we are able to get a dynamically assigned IP address, lease it for a period of time, if you remember. We also need to figure out how to resolve information that is floating around out there with namespaces, and we use DNS in order to do this. DNS is going to allow us, using the domain name service, to be able to go out and be able to make a request for a resolution to resolve or to find some sort of a resource, let's say a web server that's sitting out there, or a file and print server on your network, or maybe a domain controller, whatever it may be. Every one of those machines is going to have a unique identifier within a broader context of the network and the namespace that's associated with it. And we can use DNS to help us figure out how to find that information and effectively resolve it. DNS is effectively like a phone book. It's like calling information. It's a lookup system. It's a listing of all of the information necessary for us to find not just the namespace, but a unique instance, a machine, what we call a host, sitting within the namespace. Now, we may not have all that information sitting in one massive phone book in one location. It's actually distributed among many different servers and among many different locations, so we can look up our little piece of it, or we can go and ask somebody else if they have knowledge of the piece we need, if it's not in our copy of the book. So it's a distributed name resolution system.